All right, guys, we're going. So 8.2. All right. What does that word actually look like? It's pronounced arithmetic, but looks like arithmetic. Okay. So arithmetic is kind of like the what is it? What's the noun? That would be a adjective. It is the adjective form of sequence or series is pretty simple. Basically, the pattern is it either goes up by a constant amount or goes down by a constant amount. Each one of the arithmetic sequence. What is the common difference between as you go single time I'm going up by the same amount, I know I have an arithmetic sequence then. Okay? Like I said, pretty easy to recognize when you have one. Okay? You guys all see how that one is arithmetic still? What's the common difference this time? -3. Okay? That pattern. Simply sequence arithmetic or not, and so you just look to see, is it going down by the same amount? And explained what the concept was behind finding a rule, and you guys had to do a little bit of guess and check to try and figure things out. Okay? Which can be interesting in some regards, but it can be a little bit frustrating at times too, because you don't really know where to start sometimes. Thankfully, arithmetic sequences, it's always the same type of rule. Okay? If you know what number the sequence starts on, and you know the common difference, you can make a rule. It's a little formula for the formula. You just plug in the first term and rules for make a bit of sense as to why this should work. Okay. An arithmetic sequence. basically this right here is like a times you different. Okay? So if, let's say the fourth term in a sequence, how many copies before I get there? 3. 4, but 3 of them, right? So it's always one less than the term you want, right? So if I want like the 10th term, how many common differences would I have to use? 9, n minus 1. Does that make sense? So that's why this rule always works, okay? But fourteen, 16. So take a second, the rule for that sequence. Simplify terms, distribute, all that kind of term, right? It's not always 1. Don't always 1 when you start. But a sub 1 is the first value of the first term, whatever that was. Okay? So, right? Going up by 2s. The reason we do 1 less is because it's 1, but the whatever that difference was. Okay. In practice, that's all you have to do. Just put the simplify. Gist is same thing every time. Number you see in the sequence is the a sub 1, and then the difference is the d, and you add like terms. Term from the sequence, common difference. This is good. I need that to plug into my, but I don't need 1. So equal to 12, and my common difference is what a sub 1 was. Somebody raised their hand and tell me you guys had 5 answers all shot at me at the same time. Yeah. How would you divide by 3? Be 4 then? Okay. So a sub 1 is 4, as you claim. Then I should use a common difference of 5 to get to a sub 3. Okay, so a sub 1 is 4, plus 5. 9, plus 5. Yeah. Exactly. So we got to move. We got to move backwards, guys. Shh. Hey, I'm gonna. Okay, so when we're at the third term, if we want to get back to the first term, we have to do that backwards, subtract it twice to get down to a sub 1. Okay. This 5, like we talked about, then a sub 3 was supposed to be 12. If you put 12, it works. Yeah. How did I do what? Make a rule. First term and the difference. Do it. Difference and a term. I'm going to give you 2 terms. The 9th term is 28. Yeah. So we got to figure out both the original term and the common difference. Which one of those two things am I going to have to figure out first? Same number and get up to 28. Can get you there. What do I have to count to get up to 28? This is 3. Makes sense, though? How you can kind of work it backwards to get there for both? Yeah. These little tricks that we're talking about here and coming up with these formulas, it all assumes that the sequence is arithmetic, right? If you don't know that it's arithmetic, can't do it. Okay? You have to know that fact. Yeah. Can you hold it for like 10 minutes and I'll be done? I'm going to spend time doing that, but if you want to look at series, and it's the formula. No, this is a ton of work. You do it your way quicker. Well, let me show you how this works, and then you can decide if you like it or not. A sum of a series. When you guys had a series, what did you have to do? Plug the number in, plug right? Had to use the formula. Do that. All I need to know is the first term and the last term and how many there are, and I can get it. It's for a yesterday. You'll use whatever letter you want, but I is more accepted. Yeah. To 24. So if you were going to do it by hand, the long way, you'd have to add up 24 numbers. Formula, right? Which gives you -8. Get -7. And then that times 24. If you know that it's arithmetic. If it's any other kind of series, you wouldn't be able to do it. What? How do I know when it just gives you the equation? Well, it has to be a series. So it has to be one that's written like it's ending. Oh, we're assuming everything here is arithmetic. Sorry. Technically, with each one of these, I should say, consider the arithmetic series blah, but it works. So actually, based on any rule that's linear is going to be arithmetic. Yeah. 24 in. Because that's going to be the last one, right? When you plug 24 into the formula. Yeah, all right.